engineer. We have previously introduced the storm series in general terms. In today's part, we will go a step further and take a deeper look. Together with our export manager, Mr. Yunus, and our mechanical engineer, Mr. Furkan, we will examine the storm series steam boilers in terms of mechanical design, electronics, and automation. I would like to start with the mechanical side. What are the main mechanical features that make the Storm series stand out, especially in terms of design and continuous steam production? What is your approach?
Thank you, Güliz. Thank you. Welcome, everyone. Today, we welcome to Ekotek Academy. And also, today I will explain some of the introduction about steam boiler. The mechanical design of Storm series in basic three-pass Scotch type boilers, and also our main objective here is in the stimulus steam production under the load. Thanks to three-pass designing, flue gas and remain inside in the boiler for a long time. Heat transfer and become more efficient and large porrier and fuel energy in transportation the water. And also our designing the double in double furnaces design provide us and sinus advantage, especially a high steam capacity. It the distribution to heat the load more evenly, reduce the local thermally stretch the compensation chamber, and supports the directly and the long-term stable operation. In the shortly, the focus on our designing manufacturer's approach in the it's not the burning to more fuel, but using the general generation engineer more efficient.
The Storm series can operate with both liquid and gas fuels. How is this fuel flexibility managed mechanically? How do you ensure burner compatibility and stable operation?
Actually, it's the key point. Here is the different fuels. Actually, Güliz, sorry about the voices. The key point here is the difference fuel and have the different composition character, and therefore mechanical expression such the composition chamber geometry and keeping the flame the correction zone without touching the boiler surfaces, and also the balance it the dispersion become the critical. We don't consideration the boiler the burner as the separate the compression inside the we designing system as the boiler burner composition. Working on a single unit with this approach, regardless and whatever liquid or gas fuel in use our goal. Our goal in the remaining the same time and stable the flame, balancing the heat load a lot, and such a well efficient and long-lasting composition chamber. In additionally, this fuel flexible providers and important advantage factor the terms of cost management.
Okay, Mr. Yunus, thank you for the answer. So next question. On the mechanical side, components such as safety valves, pressure gates, and pressure switches are used to ensure boiler safety. What roles do these components play, and why are they so important?
you, Güliz. The most fundamental change in principle in crucible stack system in this safety should be never depend on single line. I mean, it can be changes different of composition. Sorry, is my microphone was gone again. Sorry. The pressure is generated also the operation, the visible monitor, and the system pressure at the any time. The mechanical pressure switch activation when a different pressure that is hold is the reach and the breach the system and into the safety condition. The safety valve is the final production of the layers. If the pressure exalted allow like the limit, it releases the pressure immediately without waiting any combination. In practical, this means that ever if the electronic system are high advantage as mechanical safety combination ensure that the system remains safe even in the worst case in the scenario.
So we know boilers are systems that operate for many years. Which mechanical aspects do you focus on to ensure the long service life of the storm service series?
Actually, Güliz, yes. Thank you for the question. We don't designing the boiler only according to the normal capacity, but according to mostly demand operation condition. Shell thickness, welding details, and the pressure wells the calculation are determined with this approach. And additionally, balance the heat dispersion, reduction local stress, minimizing the risk of the cranking and the deformation. Our goal is very clear. The boiler should be operation. What should be operation? Should operation stably at the same time stably after many years. Is this does in on the first day? It's meanings long working to unit our boiler.
Thank you very much for the information, Mr. Yunus. When the mechanical structure is this strong, it is also essential to look at the electronics and automation system that control the boiler. Now we will examine the Storm Series Steam Boilers from the electronics and automation perspective. Mr. Furkan will answer our question in this section. If you are ready, let's start with the first question, Mr. Furkan.
Hello, Güliz. We can start. If you can ask the question, you can continue.
Okay. We have talked about pressurized system on the mechanical side. Now, from the electronics and automation perspective, in the Storm Series, pressure is both controlled and safety limited. How does this system work? Could you explain us?
Okay, thanks for your pretty good question. In the Storm Series, pressure management is based on a hybrid and redundant architecture, not a single layer structure. The first is system pressure is continuously monitored using high accuracy industrial pressure transmitters. And this data is transferred to the PLC control systems, and the boiler operates within the defined set points using an automatic start-stop logic. And also this layer provides operational control. However, the safety is not left to software alone. There are two independent pressure switches, the operating outside and the operational control loop. These switches are set the maximum allowable working pressure of the boiler. And when this critical limits the pressure reach, the system performs a hard stop and shutdowns completely. And the boiler cannot restart until the pressure returns to a safe level. It means the working pressure, and to a safe level, and the manual resets in performed. These pressure switches are also continuously monitored with a safety relay. And this allows immediate detection of electrical faults such as cable disconnected or connect welding.
Thank you for your answer. Another issue that is just as critical as pressure is the water level. What kind of safety loggage is applied for water level control in Storm Series?
The water level is one of the most critical safety parameters for the whole steam boilers. And for this reason, we can say the water level control is in the Storm Series designed as a dual layer system, fully completed with international standards. And the boiler is equipped with the two independent water level switches, which are the certificated safety devices tested according to boiler standards. And this system generates low water level alarms, controls pumps, starts and stop operations, and monitors high water level as well. And also, the most important point is this: these level switches are also monitored with the safety relay. So the system doesn't only check the water level itself, but also continuously supervises possible faults such as cable disconnection, short circuits, or contact sticking. If any of these conditions are detected, the system is brought into a safe state within the milliseconds. As a result, with the relay, the boiler doesn't run dry, the pump failures are not ignored, and also the most important things, operator errors are not tolerated by the systems.
Okay, my next question are related to temperature management and sensor failures, Mr. Furkan. In addition to pressure and water level, temperature management is also very important. How does the system respond to sensor failures or incorrect measurements?
Yeah, it's actually, as you said, it's the important things. And here is the point. Throughout the system, steam, flue gas, or condensate and negative temperatures are monitored using with the industrial PT100 temperature sensors. And also, there is a clear distinction in the software logic. Steam outlet temperature and flue gas temperature are defined as critical parameters for the steam boiler systems. For example, if a cable break, invalid value, or measurement errors is detected in these sensors on the PLC, immediately switch the system to emergency stop mode. More importantly, the most important point, the system remains software locked and cannot be restarted until the faulty sensor is replaced and correct readings are restored. For auxiliary systems, a more flexible approach is applied. If a failure occurs in the condensate or negative temperature sensors, the system generates an alarm and informs the operator or the system. But it doesn't stop production immediately. With authorization from qualified personnel, the boiler can continue operating in a controlled manner. In this way, the safety is maintained while unnecessary production losses are avoided.
Thank you, Furkan, for this information. Today, we examined the Storm Series in detail from the mechanical, electronic, and automation perspective. What we shared in this part reflects how we approach products design at Ekotek and why safety is always at the center of solutions. Thank you all for joining and your interests. We look forward to seeing you again at our next live events.
Thank you, Güliz, for your kind way and also the valuable informations. As you say, we are looking forward to seeing our next live event together. Thanks.
Thank you, everyone.